Hi, Hanson.
Hello, yes.
Okay, so I think we can just go ahead since it's solved. I believe Stephen will join us before the end of this call.
Okay.
All right. So how's your weekend, by the way?
It was fine. And yours?
Mine was restful. I mean, I think I started
Stressful?
the restful.
Oh, restful. Okay, then
Yeah.
that's a good thing.
Yeah. I started the week on a high note. So I mean, hopefully it's a good week.
It's a good year, hopefully, yes.
All right. So I just would introduce myself. My name is Lanre Adioye, and I'm a technical recruiter here at the Gradient Boost. What we do at the Gradient Boost is to intelligently match companies to curated data science, analytics, and data engineering talent from across Africa. And the purpose of the call is to
You have
just
to talk a bit slowly.
all right.
Yes.
So I was saying that what we do here is to intelligently match companies to curated data science,
Okay,
analytics, and data engineering talent from
okay,
across Africa.
okay.
So the purpose of the call is to like learn more about you, speak with you about your most interesting projects in detail, and understand the kind of opportunities that you are looking out for, like in the job market.
Okay,
So I think a good place to start would be for you to share with me your career journey so far.
okay, okay. So, okay, I am Hyacinth Tampedu. So, my career journey so far is I got into this field about 3 years ago. And then so far, normally what I do now is freelance work. Either the client reaches out on LinkedIn or normally on Upwork. So basically, that's what I do now. Like the client will come with a particular project, or even it could be a company. They can come that they need this work done in this amount of time. Then that's what I do. So my career journey so far is I haven't worked for an actual company that uses data science or need data scientists. So what I do is, okay, I work in a team, like a company, for example, a company somewhere in Austria, but it's like if let's say a 3 months project, a 2 month, but not a full time position. So my career journey so far has been in freelancing. That's what I've been doing, and I'm doing currently right now.
Okay, so I understand that bit, but I think you can just help me understand the project, like the progress so far by like speaking from when you graduated, and
Oh,
maybe you
okay.
can also speak about like maybe the first few like projects you've done, not in terms of the projects, but your work. So I'll just be curious to know how, first of all, you got into data, and how like you got your first role
Okay.
and like how that has been for you.
Okay. So yes, I graduated bachelor's in 2016. And then during that time, I think I stayed home for a year. So about half of that, I've always been interested in. I got my bachelor's in electrical engineering actually. I've always been interested in computer like coding, software, and all that. But somehow when I was choosing the course, I didn't know about what electrical engineering. So I decided to choose. So after the bachelor, that's when I got interested in it. I was just searching the internet for how to get into coding, and all that. And somehow I got attracted to machine learning, AI. I think the AI bit got my interest, so I started exploring more about it. Then I decided that then I read and got that Python is a language, and I started from there. Python learned it, and then I think 6 months afterwards, I decided to do a master's in K University. Since you're in Ghana, I'm sure you know K University. So I did a
Right.
master's in K University. That was in 2018, around September. So I was in this field whilst I was doing my master's at the same time. So about a year after that, then somebody introduced me to a platform called Upwork, where you find people who need certain work done. So I got into it, and then I think one of my first jobs was to um, if I remember, it's quite a long time ago. I think it was a very simple work. Use random forest to use machine learning to predict a class of a disease given certain features. Yes. And it was quite simple. So I had to do. So that's where the journey from AI started. So then I kept applying. Then sometimes you get, sometimes you don't get as usual. Whilst I was still in school. So then I kept on building up on it. So then my school thesis, I wanted to do machine learning, but what they did was that they actually gave us the topic. So unfortunately, my thesis wasn't on machine learning. It was on AI using particle sum optimization, but unfortunately, I couldn't use machine learning for that. So, and then then from there, I kept on, going on, getting work in Upwork. But then, at first my LinkedIn was this was something that I was not really using. It's like I don't really use. And then somebody pointed out to me that LinkedIn is a very key tool in this space, because this space it's a field that it's got a software. You can actually be anywhere. And then I optimized my LinkedIn profile, and then a few times you are approached by certain people. I don't know. I think they Google. I'm not so sure how it works. Maybe they Google a particular keyword and it comes, then they contact you. And I was like, so they'll present an opportunity to you, then you do it. So it was like, when you do I think what happens is that I don't know how it works, but like when you do, the more you do, the more you get offers. So sometimes the offers comes a lot, but sometimes the offers come and then the recruiter just ghosts, So that's how it's like. So from the LinkedIn and the app, I combine them and I keep doing it. So I've been doing that for a while. Then I finished my master's in training just this year. Yes, and then so now I can't work from home. It's quite have your internet and then your laptop, and then you connect to the people who need your work done. And also what I normally do is, because this field is a very changing field. For example, when I got in and now a lot of things have changed. So you always need to keep updating yourself. So you subscribe to newsletters where they update yourself, and then you go online and learn it in order to be updated with the new things, because most of the things are old. They keep depreciating them. So you need to be updated. So that's what I've been doing for the past 4 years, since I started. And then now, so currently I have about 3 projects I'm doing, but it's almost done. So so I think that has been the journey. I don't know if this is the answer you wanted, but this has been So this has been the journey so far.
Okay. So as a data scientist, what are like your core knowledge base, or your some things that your core knowledge base?
Okay, so my core knowledge base is can I connect to you? Can I connect again using my phone? We just had lights out, in Ghana here. So I'm connecting using my phone data, okay?
Okay, no, it's fine. It's very fine. Just do what you have to do, please.
Okay, so just give me about. Okay, so you see another account of mine trying to join. Okay, so I'm ending this one on my laptop.
Okay.
Hello?
Yes, hello? I can hear you.
Okay, so so the question again, I've forgotten a little.
I said, what's your core knowledge base, like with data science?
Yes, so with data science, my core knowledge base is basically the classical data science, data analysis, trying to feature engineering, trying to find new features, trying to understand the data, modeling with machine learning, making predictions, deploying it to production, and also computer vision, the aspect of computer vision using TensorFlow, yes, I've done a couple of work towards that. But in terms of domain knowledge, the clients come from several domains: healthcare, energy, finance. So I don't have a particular niche, like, you know. So it's like what I do mostly is when they come, I have to do a lot of research. I sit up and so I understand, you know, the industry they're coming from. Then I'll be able to apply my knowledge to it in order to develop it. Yes, so that's it.
Okay. So now, what kind of opportunities are you looking out for, in terms of full-time or contract? And I mean, obviously, you seem very comfortable with working remotely. But aside that, what's in terms of like payments? What's like the base salary that you are also looking out for?
That's a very tricky question because I expected this question, but I don't know. Okay, in terms of the opportunities, yes, I'm looking for data science full-time roles because I like the freelancing, but I kind of prefer being part of a team, you know, like a full-time thing where we develop things. That's what I like. I don't like the, you know, you do 1 month, 2 months. No, it's not my style. So I'm looking for, so basically, so yes, so that's what I'm looking for, like, you know, in order to actually, you know, use data science to help the society, to help Africa. That's good. In terms of the salary, it's a bit tricky because the reason why it's tricky is on Upwork, the clients come from several countries with different exchanges and different standards of living.
So okay, dollar rate is fine if you want to
it's 5.47 years.
No, I'm asking that. I'm just saying that you can answer from the standpoint of dollar, since it's like a more universal currency.
Okay. So base salary.
But if you don't want to answer the question, it's fine. It just helps us to.
Yes. I'm saying it's not that I don't want to answer, but it's very difficult for me to answer this question because it's like,
Okay.
Yes, okay, I don't know how to explain for you to get back. Like, you know, I've dealt with people from several countries, so they can't see their money is so much different. You see, some people is high, some people is low, some people, so you get the point. I don't know. So it's like, I don't want to put myself into that corner. That's what I'm saying.
All right, that's fine. That's very fine. Okay. Yeah, so I think now I want to learn about like maybe 1 or 2 of like your most interesting projects, in the sense of how the projects came about in the first place, what the client's needs were, how you rationalized the solution, the tools you used, and the eventual business impact.
Okay, that's fine. Okay, yes. So the first one is a model I'm working on. Actually, the client is in Malaysia. He's I think a research scientist in Malaysia. He wanted a research assistant to help him. So basically, we are doing this model and writing a paper from it. The paper is almost done and published. So he wanted somebody to do work on COVID-19. He came with the idea that he needs someone to do work on COVID-19 to publish in a very reputable journal. Okay, so then he took me on, and then what's the project is basically we are trying to use, you know, certain patient features like, you know, their vital signs, their laboratory findings, like, you know, their heart rate, their temperature, whether they have a particular disease like, let's say, diabetes, and all that, in order to predict and to determine if the patient or if the future patient needs to be admitted to the ICU. You understand? So the problem statement was that since you're in coronavirus season, I think about a year ago, you saw in Ghana, it didn't really affect us, but in other countries, you saw that the healthcare system was overwhelmed. There were no beds for even those who were sick, especially I think Brazil and Italy. So we wanted to find a way that to prevent that from happening, because it was basically first come, first served. So a patient can come, he's not really sick to a certain extent, but then he'll get the hospital bed and somebody
else comes later on, that person needs access to the ICU. But because this patient is already there, the person doesn't get access and the person eventually dies. And then another thing is the patient can come, and the patient can come with a certain physical sign that the doctors might think, oh, this patient doesn't really need to be in the ICU. But maybe he has, maybe the coronavirus is now affecting him from his internals. So maybe the doctor needed to run more tests, but because they didn't, and they just used their intuition to determine, because there was no time, because the results were very limited, that patient will eventually die because it doesn't get access to it. So the thing was that we needed to find a way to make this thing, to prevent this from happening. So what we wanted to do was to build a machine learning algorithm that will be able to determine the patients who need access, who are supposed to get access to the ICU based on their features. So that's what we did. So what we did was that there was a paper which came out, I think October 2020. They did a similar study. So the idea was that, one, what we are bringing new to the novelty is that we are going to build an interpretable deep learning. What means is that we're going to use a deep learning algorithm for structured data, which will to determine the most important features of the patient. The patient has so many features. I think there are about 40 of them. So determine which of the features are most important in determining if the patient needs to be taken to the ICU. So that was the first thing that we had, and we are the first to come up with that, a deep learning for structured data using that one. And then, secondly, we also needed the model to achieve an accuracy which beats the one in the paper about, I think, 8 months ago. So basically, what we did was that, okay, basically, I did the whole work. So what I did was that the data, we were to obtain the data. Getting healthcare data is not an easy thing. But I think he had funding and all that. So he was able to obtain the data. It was in Stony Brook Hospital in US. Yeah, the patients were around 10,000 of them. And then they had certain fees, about 40 of them. So we needed to find a way to build this model well. So we used a lot of machine learning approaches. Before I continue, the deep learning model is called TabNet. It was developed by Google AI in 2018, yes. So firstly, we use a lot of, so the first thing was that, as you know, medical data is always very imbalanced. The number for every patient who had COVID-19, a lot of them did not get access to the ICU. So basically about 80% of them didn't get access to ICU, and about 20% did. So the data is very imbalanced. So the first step is for us to identify that and balance it. So we use two approaches, the smooth and then the other, which is the adaptive synthetic sampler. So what we did was that we did a lot of experiments to see which is the best result. So firstly, we did sampling. The sampling, what it does is that it balances the data set. So the second thing that we wanted to do feature extraction. So we used some dimensionality reduction algorithms to do the feature extraction, which were PCA, Principal Component Analysis, Fast ICA, which is Fast Independent Component Analysis, UMAP, Factor Analysis, and the last one is TSNE. So those were the ones that we used in order to improve the performances. Then the next step was to use the TabNet. So the TabNet has so many hyperparameters. So we use each of them, and then we run, we use each of them and then try to find the best combination to get the best result. So here, what we do was that I had to identify outliers in the data set. The way I do it is either I use a box plot, to identify if there are certain things which are outliers, and fortunately for us, there weren't. And then, and then we did that. And then, so basically, because we had a baseline paper that we were comparing to, I have to make sure that some of my things match the baseline paper. As in, they split their data sets using 90% for training and 10% for testing. So we had to do that. And I used a stratified K-fold. The stratified K-fold, okay, basically the K-fold is that it divides the data set into 5. So the first portion, I use the K of 5. The first portion trains first, and the next, and then you find the average. The stratified, what is that? Is that stratified is used for imbalanced data sets. So what is that? Is that it tries to make sure that each of the 5 have equal number of samples, so that it takes care of the balancing. So then I first experimented with the dimensionality with the sampling techniques to see that would be the best performance. Then experimented with the feature extraction techniques. Then I experimented with the hyperparameters. So the hyperparameters were a lot, I think about 10 of them. For example, gamma, I think gamma was one of them. The number of steps, and it's like there are a lot of it actually. So we experimented and we put the results in the table. So that we had about 20 tables which contains all the results. And we take the best result from each of them. So finally, after all this, we got a particular result which contained the best, a particular features which contain the best. I think with the dimensionality reduction factors, the first ICA did, and then the sampling of the Anderson and all that, and then compared with all of that, then we were able to get a result. So the metrics used was that we have to make sure we use the same metrics as the paper did. The mean metrics was the area under the curve score. Yes, and then it was accuracy, F1 score, precision, recall. We have to make sure that it matches it, and then good enough for us, all the metrics from our paper beat the other paper. So that means that we solved one of them. And then we used, so the second point was to determine the features which are most important to a patient needing ICU. So the way the tablet model works is that it has something called, a feature called a mask, which identifies the most important features. So it's like you plot something like a heat map. So all the 40 features. So where the mask is paying most attention to, it will light up. And then where it's not paying most attention to will be dull. It's not lighted up. So it's like you look at it and then it does it for all the time that you run the experiment. So eventually, that's a local feature important that we plotted. So the global feature importance is what, somebody who doesn't have a good idea about the tablet to understand, where we just used something like a bar chart, where the longer the bar, the most important it is. And we identified, we arranged them in descending order, and all of them should add up to 1, or basically 100%. So we identified, and I think ferritin, which is something like the patient's anemia. I think anemia was the most important feature. I've forgotten the other features, I have to refer, but I think the ferritin was the most important thing. And then, so we got a good result of about, I think our AUC scores around 94% compared to their 84% they had. We also use a confusion matrix to plot, to see the number of patients that the model missed. For example, if a patient was if a patient was admitted and the model said it didn't admit, or if the patient didn't admit and the model said admitted, to see the number. And that was a very low number. So the confusion matrix was also used to work in our advantage. And then, yes, and then the paper was written in something called latex overleaf. So that was how the model was built, and then everything was gotten. And then so far we are at the final stage of publishing. Maybe this week or next week we will submit it for publishing. So that is one interesting thing that I did. It took about 3 months, I think.
It actually sounds very interesting. I'm actually curious to know about, did you do this just yourself and the client, or did you work on this with the team?
No, it was I alone. So what the client does is that it's like, you have to make sure that even though you are the one doing it, you have to make sure that you satisfy what the client wants. So it's like, after I think every week I send a progress report to him. So he checks, but he didn't really, what he did is that maybe, okay, you have to do this. So basically I did everything from the beginning up to the end. The client just checks to see if what I'm doing matches what he wants or what is required, yes. But there was no other team, I was the only one, yes.
So, I mean, you had to like clean the data,
yes,
do all those processes.
Yes, I had to do that.
Well, okay, so I mean, in brief, can you just recap what the project was about, and the process, not just the methods you use, not necessarily in depth, like
Okay.
from script cleaning the data to the next step.
Okay.
And yeah.
Okay. So the project, as I said, I've explained what it's about. You want me just briefly explain what it's about again?
Yeah, just briefly, yes, please.
Okay, so the data, so basically we import the data had certain issues like missing data, I think outliers, incorrect data types, duplicates.
But can I butt in here in terms of the data? The data was for people who were COVID-19 patients, right?
Yes. COVID-19 patients, yes.
Were they already in the ICU or just all the data of all COVID-19 patients?
No, the data contained data of COVID-19 patients, but not all of them were in the ICU. Most of them were not. That's why I said it was an imbalanced data set. Yes, most of them were not in the ICU.
Okay, I understand. And this was from patients who were in a particular hospital, or was the...
Yes. In the hospital is called Stony Brook in US.
Okay, all right. Okay, please go on.
Okay, so the data, as I said, it had issues like missing data, outliers, duplicates, I think incorrect data types too. So it had to be cleaned using the normal to like pandas and matplotlib to visualize and all that, Seaborn, NumPy. Yes. So then after that, then we did. I think the next stage was a bit of EDA, which is explorative data analysis, to understand the data. So that's what we did. EDA. Basically, the basic tools were pandas and NumPy. I used that to understand the data. And the next step was to balance the data set. I used both Smoot and Anderson to balance the data set. And then the next step was to use the dimensionality reduction factors, which I said were 5. PCA, Fast ICA, UMAP, TSNE, and factor analysis. Yes, to extract features out of it for improved performances. So after that, then I went into the modeling aspect. So I split the data was split 10% for training, 90% for training, 10% for testing. I used a stratified K-fold, which divide the data into, I use K of 5 into 5 segments or 5 partitions. The stratified ensures that because it's imbalanced, the stratified ensures that equal number of samples are in each partition. Then the model, then the tablet model was trained. So it was trained, and I did a lot of hyperparameter tuning to find the best combinations. So eventually we were able to find the best combination to the model. So we call that one optimized tablet. And then the other one was called baseline. So the baseline we didn't tune any hyperparameter. We use the baseline, what the hyperparameter, what the tablet model comes with. So we compared that one and realized that the optimized one performed better, which was obvious. So then basically then we use metrics. The key metric here was the AUC score. Also, we plotted it in the precision recall curve. Precision recall curve is a curve which is used to find the balance between precision and recall. We use the one normally for imbalanced data sets. So then I found the accuracy, F1 score, recall, precision, and also built a confusion matrix out of it. So then eventually we compared our results to the results of the paper. He used, I think, artificial neural network. Yes, he used artificial neural network in his paper, which was published in a very yes. So then we compared our results, and our results were better. And also we were able to plot and see the features which are most important. So the reason why we use the features which are most important is that sometimes because the features are 40, it's difficult for the doctors to actually take every patient's features like the laboratory finding, their temperature, their heart rate level, whether they are this or that. So we use as the most important thing. So the doctor can decide to use only 10 of them. So the most important features you can even use 5. The most important of them using our model. So let's say our model depicts that these are the 5 most important ones, like temperature, the temperature of the person, whether he had diabetes and all that are the 5. So you can only use that one to determine and then make a quick and useful decision in determining who goes to the ICU in order to save lives. And the second reason is that, I think that is the most important reason for that. And the output of the model is to use to assist the medical personnel global. Even though this model was built in, the data was quoting from US. The model is good enough to generalize even in Ghana in our hospitals. It can be used here in our hospitals so that they're able to prioritize the patients, because there's very limited resources for everybody. So they have to be able to prioritize the patients because of the limited resources, so that the doctors will to get the necessary tools to be able to determine the patients who need ICU and those who need it in very time bound, because they have a limited time to do that. So I think that is the key results from the model or from the project.
Okay, all right. I think I clearly understood what you
Okay.
just said now.
Okay.
So, but how, in terms of the I mean, I'm just thinking about the ethical implications of this project.
Okay.
How was that like determined by you, or I mean, is it something you really cared about?
So, yes, it's something that we cared about. But the interesting, or the, should I say, the lucky thing for us was that, as I said, this we were comparing our work to somebody else. So the model, so those individuals were the ones who got the data from the hospitals. So they took care of all that ethical issues, made sure. So number one thing, there was no patient name, nothing, it was just ID. So we don't know who the patients are. So that's one key thing, yes. So they took care of all those ethical issues and all that. So what we did was to obtain the raw data that they had. We didn't obtain the clean data from them, no, it was the raw data. I think the clients had the resources to obtain that from them. One thing is, it is not easy to get medical data. It is not, because it has a lot of medical, ethical implications. So in terms of ethical implications, the other paper took care of that. We didn't need to do that.
Okay, cool. That makes sense. Then how did you like assess the quality of the data that you got? Or I mean, I think you probably answered that because you used data from
yes,
I mean,
exactly.
a source that had already worked on it. But then in terms of cleaning the data, was there any challenge on that end?
No, it's something that I normally do, so it's not something that I had a lot of time. You just have
How
to.
How did you do that?
Yes, as I said, so firstly, what I do is I check for missing values. So the tools I used were Pandas, Python basically. So Pandas for NumPy, Matplotlib, and Seaborn. So if there's any extra thing to do, then I use that too. So firstly, I check for missing value to see if any patient's record was missing. Then I check whether the data type, for example, if a feature is, let's say, temperature, and the temperature is, let's say 32 point this, 31 point this, and the data type of that safe is a string, which means they are words. That means that is wrong, because these are actual values.
Right.
To be afloat. So then you need to correct all that. And then I check for outliers. So to see if sometimes outliers, you don't need to remove them. It depends on the situation. For example, if most of the patients come and all the patients have an average, or most of the patients, let's say they are let's just say their heart rate, let's say their blood pressure, the systole is between the systole is supposed to be, I think, 120. So if the systole is, every patient is between 100 and 140, and you see a patient with around 300, that shows that it's an outlier, and then you know that outlier is wrong, because a patient with that systole is supposed to be dead. Yeah. So you have to take care of that outlier. So firstly, the way I do it, I visualize with box plot. The box plot gives you a visual representation of like the percentiles of plots, the 25th, the 50th, the 70th. So if you see any point which is outside the minimum and maximum range, so then you think about it to see, the value of that. So you filter it and see, no, the value of this patient's, that 360 is not right. So it's something that, it needs to be removed. But if you look at the value, let's say they all between 100 and 140, and so somebody has 70 or 150, they know that it's possible that maybe that patient's had systole, which is the blood pressure, the first part of the blood pressure is wrong. It's not that it's wrong, it's possible. Now that patient had a very high blood pressure. So that data point, even though it's an out there, it's important to be included in the data. So what you can do is that you can actually, sometimes I leave it like that, but sometimes what I do is I try and scale it into maybe scale it so that it comes within the range, but I note it down and work on it. Yes. Okay. So another thing is duplicate. Yes, sometimes one patient can come and then maybe the data entry would enter that patient's information about 4 times, which is not right. So I try to remove the duplicate. I have to investigate and see all of them. Even though the data is large, it's important to take care of each of them individually. So I take all the duplicates, and then what else on the data clean did I do? I've forgotten a bit about it, but I think another thing I forgot to mention is that I had to do feature scaling. Feature scaling. I think I use a standard scaler where I scaled all of them to a mean to 0 mean and the variance of 1. So what the scaling actually means is that, let's say a feature comes and let's say there are 2 features. One of the features is just between 1 and 5. So those are the values. And another feature comes, and that feature is between 100 and 300. So the way the machine learning model works is that the one between 100 and 300 will dominate the model so much that the model will think that is a more important feature than the one with 1 to 5. So to keep paying more attention to that model when trying to do the pattern matching in net algorithm. So I have to make sure that I scale every feature between 0 and 1. So that's what I did. I forgot to mention that. I think I forgot to mention that. Yes.
Okay. All right. So I mean, if I'm to speak on the results from this project, it was basically for to determine based on the data the likelihood of the COVID-19 patients that would have to be admitted in the ICU based on the data that you had.
Yes. So that in the future, if let's say for example, a patient comes to the hospital today, the doctors can just run about 5 either laboratory on the patient using the feature importance. So then we run this model and then see the likelihood based on the 10,000 patients that they've done, which the data could have been bigger, but let's say it's a good enough data set. They can determine if this patient actually needs to be admitted to the ICU or not.
So that's, I mean, is it to prevent emergency situations where patients die or what?
Yes. So basically, because the key point is about the resources and time. So now the doctors don't have there's not a lot of resources. I mean, there are not a lot of ICU beds to take care of every patient who comes to hospital. So because you've come to a hospital that you have COVID-19 doesn't necessarily mean that they have to admit you to the ICU and pay keen attention to you. No, somebody can go to the ICU with COVID-19 and just has mild symptoms. Imagine such an individual is admitted and somebody else comes who has bigger or should I say more intense symptoms, but the doctors tell them that the ICU is full. Such a person might meet his or her end because somebody who didn't need to be in the ICU was there, was occupying a bed. So this one tries to filter it out. So it tries to prevent that this from happening. So let's say this model was there in the beginning of COVID-19. It could have prevented a lot of deaths, as in patients who didn't need to be in the ICU wouldn't have been there, and patients who needed to be in the ICU would have been prioritized, given more attention to. I hope you get it.
Yes, I do. All right. So, I mean, this seems like a very interesting project. What was the most challenging part of it?
Let's see. I think the tablet model, I think understanding how the tablet model works, because you have to understand how because it's something that it's not really being used by a lot of people. So it's like you have to understand. Okay. The first thing is trying to find the first challenging part was trying to find the what's the word, the contribution to knowledge. Contribution to knowledge in writing any research paper, you have to find the contribution to knowledge in that. What are you adding to knowledge that is not already there? And second, understanding how each of the hyperparameters and each of the steps of the tablet works was challenging, because it's a combination of a lot of algorithms and all that. So trying to understand how each of them, in order to map it in your mind, in order to build a model, to tune it, to know which one to use here, was the challenging part of it. Yes.
Okay. All right. So I think away from that particular project, for the projects you did for the credit card fraud detection using Tabnet, how did you get the data set?
For which one?
Credit card fraud detection.
Okay. That project, in terms of the data, it's this one is also another thing that has ethical issues. Credit card, getting data on credit card is almost impossible to get. So there's basically this data was, I think I derived it from, I think I obtained it from a website, I think. Yes, it was from a website. It's just like, they've also masked the individual information. It's just been replaced by V1, V2, V3, V4, V5, V6, even though those V1, V2 represents patient's information. Yes, so I obtained that one from the website, I think so, yes.
Okay, and so in general, could you just explain your the process for documenting your projects through technical documentation as you run your experiments?
Is it the credit card?
That it is your documentation process, when you're having technical No, in general, I mean, it could be or I would assume that it's sort of like a standard.
Can you repeat the question? I got lost somewhere. Yes.
Yes. So I'm saying that, can you please explain your process of documenting your project through technical documentation and how you run your experiments in a way that you understand, in a way that is understandable, reproducible, and sustainable?
Okay. That is okay. What I normally do is when I'm writing my code in my notebook, I do comment on everything I do. For example, let's say if I get a finding, I'll make another markdown below it and document what actually I found. So it's like what I actually did. So that anybody who is a technical person, knows data science, will to look at it, oh, this is what you did. And then most of my code that is not from any client, a personal project, I put them in my GitHub. So the person can actually just go there and, but no, I normally don't put data sets there. I don't know why. So the person can go there and, so if the person wants to reproduce this work, he can do it in the same way that I did it. Maybe the person wants to learn, he looks at how I did it, maybe use a different model, maybe find different features in it just to try and, I don't know whether it is the kind of question you're asking to do. Yes. So
I think it's, yeah.
Yeah.
Okay. Do you run experiments? Is it something that you usually do?
Yes. In terms of the work, I said I run experiments all the time. Yes, I have to. I do. By experiment, do you mean you experiment with this and then you try this and this?
Exactly.
Yes. As I said, regarding for example, the work I did on the medical data, I had to run so many experiments using the different dimensionality factors, the hyperparameters. And when I ran it, I document it I put it in a table, for example, the table heading is, let's say, varying momentum. So I'll vary the momentum, let's say momentum 0.02, I'll run 0.04, 0.06, 0.08. So then I run it and then I take, hey, you understand? So I did a lot of tables. When I finish, I combine them. But also, moving away from that one, there's a function called grid search and random search where allows an individual to run a combination of things. For example, let's say random forest and XGBoost have hyperparameters called number of estimators, which is the number of trees in the forest, and then the learning rates, for example. So, for example, you can list now the number of estimators, let's say about 5 of them, about 5 learning rates and all that. And then you run, so what it does is that it runs a lot of combinations and it outputs all of them. So when it gives you which of them gives the best combination so that you use that in your further analysis. That also does that, yes.
Okay. So in general, I mean, when you work with the clients you work with, what's the usual, how do you usually communicate your findings and how is your presentation usually received? So is it a process where step by step you have that conversation with the stakeholders, or do you just work and present your findings?
No, it depends. They all have different ways of doing it. But most of them, what I've realized, most of them want to use AI and machine learning, but they don't necessarily understand anything about it. So sometimes you need to present it to them step by step, like whatever you are doing. Explain. For example, sometimes if it's a project like 1 month, sometimes every 48 hours, every 2 days, I have to present it to them. Sometimes via Zoom, sometimes via chatting. I send them the notebook via normal texting to explain. But those who really understand it, it's like, as I'm doing, I give them heads up, like, for example, hey, I have finished this and this, so I'm moving on to this. They can say, can you let me see this? Or okay, proceed. Or okay, you see, it depends. The client they're very different. Everybody is very different, so it depends on what they want. And normally, what I do is I have to do what they want, So I can't say this works for this. No, they have to tell me what they want, and I do it.
Okay, I mean, are there cases where you guys conflict in like what you think, and how do you make your position clear in such a way that they are able to maybe either use your position or has there been cases like that?
Oh yes. The conflicting sometimes, what I've noticed that the conflicting comes in when the person doesn't necessarily understand the machine learning aspect. So it's like, for example, you do something for them, and what I think is because they don't understand, maybe they will ask somebody who is near them somewhere, and the person will say this. So normally what happens is that I will explain to them why I did this, but it always ends in them doing what I'm saying, because what I'm saying is, I won't say it's always right, but I give them the logic behind why I'm doing it and what I am doing. But sometimes the client can say, no, do it this way. It's like, that's what the person wants. So it's like, even though, for example, I'm saying 1 + 1 is 2, the client is saying 1 + 1 is 3. You tell them no. They'll say, so what? You have to go with what they're saying because they're insistent on it. I don't know why they want that, but sometimes they're insistent on it.
Okay, so I mean, have you had cases where you've collaborated with multiple people on one project?
Oh, yes.
Okay.
Yes, I collaborate. I think that is okay in terms of freelancing. No, I normally do it solo, but normally I was on. I don't know what have you heard of Omdena?
No.
Okay, Omdena is like it's like they get 50 collaborators from across the world, and then you collaborate on the projects. So it's normally for experience and all that. So I did one on Need Energy, where we collaborated with 50 people from across the world, all across the world. So it's like we use Slack for communication. We used Git for pushing and committing the work. the work is on GitHub, and yeah, so it's like, yeah, we communicate with them, and then we have meetings every Sunday, and we have subdivisions where we meet. For example, my group met on Tuesdays, but the whole group meets on Sundays to present our findings. So it's like a 2-month thing. So that's why we collaborate with them. And also a second thing is that I collaborated with them. That was I think there were we were 4. I think 2 from India and 1 from Australia. We built a computer vision model to detect to predict pneumonia in chest X-ray images. I think that was for competition, so it wasn't really. So it was for competition. So my duties were, I think, yes, okay, yeah.
All right. So when you get stuck doing your personal project, you have cases when you get stuck. How are you able to figure out what to do?
Do you mean a collaboration?
No. I mean, like when you are working like by yourself, and then I mean, for example, the COVID-19 project. I don't know how it all went from end to end, but if there are cases where you get really stuck and you're not sure what to do, how do you manage those situations?
Oh, I like researching a lot. I go to the internet is a very open world. I go to Google, I go to YouTube. I have to read. Sometimes I read a lot of papers in order to get some idea of that. And yes, and where I am in terms of physical contact, nobody really understands machine learning where I am. So if I'm stuck, I have to do it on my own. It's just recently that I started reaching out to people on LinkedIn. So now I know some people who are into it that I can, if I need help, I can ask them on it. But first, I have to use to the internet. And sometimes the information that you need is not on the internet. Sometimes on rare occasions, but sometimes it's not. So regarding that one, I have to, it's interesting. I have to try and find a way around it, and somehow I get it done. Yeah.
All right, cool. So what would you consider to be like your biggest strength, like technically? Say like your area of focus, something that comes very easily to you. And also what's that tool or point where it's not so much fun for you?
Oh, my strength. Okay, it's not so much fun for me. Do I know? I don't know how to. I don't really know because.
Oh no, like okay. So in terms of your strength, what's like your the ones that you do easily, your core?
Oh, okay. In terms of my strength, I'll say the whole data science process, like, is my strength. Like, and then also one thing that I think comes easily to me, maybe not to others, I'm not sure, is when somebody comes with a project in a domain that I've never worked on before. I don't know whether maybe because I research a lot. It's, for example, the person can come today, I'll have to do research and then sometimes 48 hours. So within that time, I'll have a good knowledge about it and how to start it. So I think that's a strength to me that I have in order to, so it's like basically I can easily adapt to any of the industries or any of the work that the individual needs. So in terms of weakness, okay, let's see, it could be, I don't know.
Okay, no problem. So in terms of your soft skills, so I don't know if you like fully understand soft skills, but what would you say is like your areas like that you excel in and areas that you're trying to improve on?
Okay, the areas I excel in is teamwork and communication. Yes, I'm a very good team player. I'm very easy to talk to and not. Like, I take your ideas into consideration. We have to, I like collaborating with others more than on myself, so that in terms of when we hit a rock, I can actually ask somebody or just, so it's like my soft skills may be teamwork, communication, and also taking what's the word? Taking initiative to do something. And then what I'll work on. Okay, let's see. Okay, maybe what I need to work on is maybe when I know I've done something really well, and then the client comes and maybe not something I need to work on, but it's something that happens a lot. Like, the client can say, do ABC, you've done it. Then the client can say, do EFG, which is not part of the recommendation. So it's a bit some way. I don't know. So it's like
But you eventually do it.
yes, I will eventually do it, but maybe for certain
Like within your scope.
or for certain it depends. But normally, I eventually do it, and maybe for certain conditions, yes, yeah, I think so.
Okay, I understand that. So I mean, it has been a very interesting conversation so far.
Yes,
So I want to know, do you have do you have any questions for me?
The first question wasn't answered, and the guy didn't come to answer it.
Oh yes, I've had a conversation with him already. He unfortunately couldn't join us. He also had another call to be on. So he's going to email you the answers. But right now we're what's functional is like the mock interviews. So you mentioned the question you asked was about peer-to-peer rating, right?
Was what?
I think the question you asked was on the peer-to-peer rating.
Yes. So we can get access to it so that we can improve upon what they are saying.
Exactly. So that's actually on the pipeline, because I mean the company is relatively young. Started out last year and all of that. So that's something on the pipeline. Although right now I think we are I mean mock interviews are sort of functional right now, but something that is being worked on. But I would also, aside from this answer, I would have him contact you so he can give you more information on that.
Okay. Do I have any questions? Yes, also, I don't know why your email went into promotions. I don't know why. So it nearly escaped me.
Oh, wow.
Of Gmail, it didn't come to the primary. So, but I normally check it. But I'm sure if it goes to promotions, others might miss it. So maybe something that you have to work on. I think it's the way the email starts. The promotion is like promotion goes when the email looks like a very general thing.
Right. Yes, okay.
So
yeah, that's. I thank you so much for that feedback. And I'm wondering that's probably the case with like other people. Yes. People that probably just focus on their primary meals. So thank you so much for that feedback. We're going to apply that. Yeah. So Hyacinth, it's been a very wonderful conversation, and we're going to we're going to use this information to, like, the internal team will evaluate the recording, and they'll be able to I mean make decision based on this. So all right, thank you so much, and enjoy the rest of your day.
Thank you. Yeah, you too. Thank you. Bye-bye.
Bye.